Hey guys, today we're going to be covering 11-5. 11-5, our objectives, we're going to organize data in two-way frequency tables and use them to make inferences. So last section in the chapter, 11-5. So two-way frequency tables. So let's dive right into a problem. Owners of a major food chain are planning to add a vegetarian item to its menu. Customers were asked to choose one of two vegetarian items. Okay, and the two items are shown here in the chart, a burger or a pizza. Results are shown in the table. What trends do the results suggest? Okay, so I'm looking at this table. I'm looking down on the column, veggie burger. I had 50 males and 60 females, so a total of 110 people tried the veggie burger. The veggie pizza, okay, I had 40 males and 75 females for a total of 115 people that took that. I read across the rows, okay, this is discussing just males. Okay, I had a total of 90 males, 50 tried the burger, 40 tried the pizza. Total of 135 females, 60 tried the burger, 75 tried the pizza. Okay, grand total is 225. What we want to talk about now are the joint frequencies and the marginal frequencies. Joint frequencies indicate the frequency of a single option for one category. For example, the frequency of males choosing a veggie burger. Okay, I like this definition up here much better. Okay, I think this one makes more sense. A joint frequency is at the joint of a column in a row. Okay, it's where they join each other. So like 50 males took the veggie burger. Then we have something called the marginal frequency. Marginal frequencies indicate the total frequency for each option or category, such as the total frequency of female respondents. Again, I think this definition is better too. A marginal frequency is at the margin or the edge of a column or row. Okay, so notice they put the joint frequencies here in blue, and the marginal frequencies are the totals in red. Okay, so what do our trends suggest? So if I look at it, it looks like more males preferred the veggie burger, okay, if I'm reading across the males, and more females preferred the veggie pizza. Okay, you could also say, let's see, I had almost even people. Okay. So joint frequency suggests that male customers prefer veggie burgers over veggie pizzas, and female customers prefer veggie pizzas over veggie burgers. Marginal frequencies suggest that all the respondents showed only a slight preference for veggie pizza over veggie burger. They also indicate more males than more females than males were surveyed. Okay, so if I look here, I have 115 to pizza to 115 to the burger. So those are close. But then I look here, you definitely see a lot more females were surveyed. Okay, so that's kind of what we can look at. Okay, so now same data here. What did the marginal frequencies tell you about the number of male and female respondents? Well, we had a lot more females than we did male. So that is what this tells me. Okay, same data, we're going to look at this slightly differently. Now, owners of a major food chain are planning to add a vegetarian item. So again, same data. The question we want to know in here, what do the survey results reveal about male and female customer preferences for veggie burgers? So with this, we have to get into something called joint relative frequency. Joint relative frequency is the ratio or percent of the joint frequency to the total. So to do this, we take the joint frequency and divide it by the total. Okay, joint frequency divided by the total. Okay, and notice we want to look at veggie burgers. Okay, so to do this, I'm looking at the total. Remember, our total was 225. So I'm just going to take each cell and divide it by 225. So I had 50 male veggie. So 50 divided by 225, throw that in the calculator, you get 22%. And you can round to the nearest percent. Okay, female veggies, we take 60 out of 225, 27%. Veggie burger, we had 110 total out of the 225, gives me 49%. Okay, moving on to the pizza, we had 40 males who liked the pizza, so 40 out of 225 gives me 18%. Females that like the veggie pizza were 75 out of the total 225, 33%. And the veggie pizza total, we had 115 out of 225 people, so 51%. Okay, and then we look at the male total. We had 90 out of 225 were males, so 40% of people surveyed were male. Okay, female, 135 out of 225. 60% of people surveyed were female. And of course, total, 225 out of 225 better give you 100%. Okay, also notice the total here equals 100%. And then if I take this total, I also get 100%. Okay. So we care about the veggie burgers. So I'm looking at the veggie burger here. Of the customers surveyed, about 22% were males who selected veggie burgers. Okay, I'm only caring about this column. And 27% were females. So a greater percent of females than males selected veggie burgers. Okay, because 27 is greater than 22. Okay, so how can you tell whether a greater percent of customers surveyed selected veggie burger or veggie pizza? Okay, this is where we look at our margins. Okay, we had 49% pick the veggie burger, 51% pick the veggie pizza. So which one was bigger? The veggie pizza. Okay, I look at my marginal frequencies here. Okay. Okay, still the same data, but this time we're going to look at what they're saying here. A marketing team concludes that females prefer veggie burgers more than men do. Do the survey results support this conclusion? Okay, so we're again just concentrating really on the veggie burgers. I want to know if more females or males like it. Okay. So what we do here is we look at something called the conditional relative frequency. Okay, conditional relative frequency is the ratio of the joint frequency and the related marginal frequency. So to do this, we do the joint divided by the marginal. Now you could, a lot of people want to look at this and say, oh, more females liked it because we had more total number of females. However, it's 60 out of 110. So you need to really look at the percents here. Okay, so we got to change everything to percents. So calculating the conditional relative frequency for each row will adjust for differences in the number of male and female customers surveyed. Okay, so see, we've got different amount of male and female. So to do this, again, we are looking at gender. Okay, we know we're concentrating on the veggie burgers, but I want to know males versus females. So I have to use the total for male and the total for female. So males, we're just going to divide by the total number of males. So I had 50 males like the veggie burger, so I do 50 divided by 90. 56%. Again, males, 40 out of 90, 44%. Again, notice these two added together give me the total. And then the female row, again, we're looking at out of the 135 females. So we do 60 out of 135, it's 44%. And 75 out of the 135, 56%. Okay, and again, total 100% females. So the survey wants to say that females prefer veggie burgers more than men do. So if I'm looking at my veggie burger column, 56% of males preferred it, 44% of females preferred it. Does our survey results match what that customer wants to say? No, the results do not support this conclusion. The conditional relative frequencies show that while about 56% of the males surveyed prefer veggie burgers, only about 44% of the females prefer veggie burgers. Okay, so this conditional relative frequency is very useful when you have an uneven amount of people in the two categories. Okay, so what conclusion could the marketing team make about male and female preferences for veggie pizza? Okay, so who likes veggie pizza more, males or females? Well, if I look right here, oops, okay, 56% of females prefer the veggie pizza while we have 44% of males. Okay, so we would say females prefer veggie pizza more than males do. Okay, still working with the veggie pizza. The marketing team concludes there's a greater variance between the percent of men and women who like veggie pizza than veggie burgers. Did the survey results support this conclusion? Okay, remember variance, how much do they vary? So to do this, we're going to calculate the conditional relative frequency for each column. This allows you to analyze male and female preferences within a food choice category. Okay, so this time, notice how we really want to focus on the difference between the pizza and the burgers. Okay, so that means we're going to divide by my total down here in the column. So at this time, I'm dividing everything by 110. So, or at least for burgers, I'm dividing by 110. So 50 divided by 110 gives me 45%. 60 divided by 110 gives me 55%. Notice those two add up to 100%. Now I'm looking at the veggie pizza. I had a whole total of 115 people pick the veggie pizza. So I'm going to take 40 divided by 115, I get 35%. 75 divided by 115, I get 65%. Okay, so we like to say there's a greater variance between the percent of men and women who like pizza than the burgers. So let's talk about the pizza. The variance, again, is how much difference is in between. So if I'm looking from here to here, I vary by about 10%. Here to here, I vary by about 30%. So which one has the bigger variance? The pizza does. So the conclusion is supported by the survey results. Conditional relative frequencies show that of the customers who prefer veggie pizza, 65% are female and only 35% are male. Of those who prefer veggie burgers, 55% are female and 45% are male. Okay, so what conclusion could you draw from percentages for male and female customers were the same across the rows? Well, if they were all the same, then you could say that it's equally likely that men like burgers as they do pizza. Same thing with females. So now we're going to be given some frequencies, and we need to figure out what those mean. So a random sample of spectators entering the stadium were asked whether they were cheering for the Bears or the Tigers in the championship game. Samples categorized according to gender and team. So what does the joint relative frequency, 65 out of 230, represent in this context? Well, let's take a look at where those numbers are. 230, that's my total. 65, I see it right here. So this says there are 65 males cheering for the Tigers out of 230 total people. 65 males cheer for Tigers out of 230 total people. Okay, that's what that is saying. Okay, and I just find that by looking for those numbers. Okay, so now we're going to look at the relative frequency. So we have 49 out of 93. I personally always look for the denominator first. Okay, so 93 is here. Okay, that's total females. So now let's look at 49. 49 is right here. So 49 out of 93, that means of the females there, 49 were cheering for the Bears. So 49 out of a total of 93 females cheer for the Bears. Okay, again, you're looking for those numbers. Okay, try this one. So what does the conditional relative frequency, 72 out of 137, represent? Well, 137 is here. That's the total males. 72 cheer for the Bears. So 72 out of a total of 137 males cheer for the Bears. Okay. Okay, and that's what I've got. So just to sum it up real quick, two-way frequency tables show relationships between two sets of categorical data. Entries can be frequency counts or relative frequencies. Entries in the body of the table are joint frequencies, or counts, and joint relative frequencies, which are ratios, or percents. Entries in the totals column or row are marginal frequencies, or marginal relative frequencies. Okay, so then conditional relative frequencies show the frequency of responses for a given condition, or the ratio of the joint frequencies to the corresponding marginal frequency. Okay, remember the margins are down here and over here. The joints are in the inside. Okay, conditional relative frequency, you divide by whatever category you're looking at. So like this one, It's looking at students versus adults. This one is looking at afternoon versus evening. Okay, so just really pay attention to what it's asking for. Homework tonight, you're on page 499. You're going to do problems 10, 13 through 16, and 26. Please make sure you're reading directions carefully and showing all work. Hope you guys have a nice day.